We are on the section of completing the square. Anybody remember doing that in Algebra 2, completing the square? All right, this is a little different though. When you did it in Algebra 2, you actually solved for your x or your zeros or your y-intercepts with it. Our purpose for doing it now is to get the vertex form of a parabola. So it's going to be a tiny bit different. That's why I want to do it at least twice for you today. Because the way I used to teach it when I taught Algebra 2 is I would take the constant over across the equal sign and work that way. We don't have an equal sign here. We don't have a zero. So we're going to do the steps. My brain, the type of learner I am, these steps do not help me. But some of you, they do. I would rather see the problem, but I'm doing it both ways here. So we are going to convert from standard form of a quadratic to the vertex form of the quadratic by completing the square. When you complete the square, you get a perfect square trinomial that is easily factored. Life is good if our squared term has a coefficient of 1, because then you can just jump right in. It's not always going to be that case, and I'm even going to throw a fraction at you tomorrow. But if your coefficient of your squared term is 1, the first thing you're going to do is isolate your constant. And by isolating your constant, I mean you're going to put parentheses around your ax squared and your bx. And you're going to leave a space. And your constant is going to be kicked out. He's going to be all by himself for a little while. He'll get a friend, but not right away. And actually, I'm going to change that K to a C. It's going to be a K at the end. I'm thinking of Kentucky Fried Chicken. Anybody thinking KFC? That's how does stuff pop into your brain like that? Like when you see, yes, it's so hard. And then I get sidetracked. And now I'm going to have Kentucky Fried Chicken for dinner because it's on my mind. It's so hard to do. Okay. The next thing you do, completing the square. Do you guys remember who you take half of? There's taking half of something. And I know we're dusting off the cobwebs. You're going to take half of that number right there. You're going to take half of the term that's b, and then you're going to square it. So much easier when we have numbers. So you're going to find half of b and then square it. You're going to find that value to complete the square. You're going to add this value to complete or make your perfect square trinomial. Like I said, these words don't help my brain. But if they help yours, that's why I'm doing it. But this is where we differ from Algebra 2, because normally you would have moved this constant across the equal sign and then put the half of the value squared over there. We can't do that, but we can't change the value of the problem. So this is the new step. We're going to subtract the value of c to get k. It's easy when we do it, confusing in words. And then you're going to factor to get that vertex form. Looks like a lot, but it's not. It's basically what you did. Hi. Absolutely. Yes. Yes. Now, if I'm not in homeroom tomorrow, I don't think we're having a student count like what you did, but there's just the one difference. Can I flip? Yes.
What's the 1/2 in the vertex form?
Oh, no! Nothing. It should be A. Good. Did I just give you guys lollipops? guys monopolized on me talking to Kayla. Good job. All right, let's see what this is going to look like. So our function is 2x squared plus 4x minus 1. That's our standard form. Our goal is to get it in vertex form, not with the 1/2 out front. Okay. Step 1 of our little steps said to make this coefficient a 1. So if I factor him out, do you agree I have an x squared left? Because if I distributed him in. What would I get if I pulled the 2 out of the 4x? 2x. But our steps also said you have to kick out the constant. So we are not going to let him in. We're going to keep him, but we're going to leave a space to make that perfect square trinomial. Yes, Alyssa?
I was just going to say like,
Yes, yes. You are ahead of me. Very good. All right. To complete the perfect square trinomial, you take half of that guy, which is going to be 1. Half of 2 is 1, and then you square it. So I'm going to add the 1 right there. But this is where it might be a little different from the algebra 2. Because it's really not a 1, it's a 2. But we can't change the value of the problem. So you're going to add the opposite so that if I distributed it and added it or subtracted it, it would make it go away. So you're always going to make sure that when you do it here, it is the opposite. All right. That's the only part you might have trouble with tonight. Do you agree I can factor him into x plus 1 quantity squared? Anybody have issues with that? All righty. And then do you agree we get negative 3 right there? Confirm or deny. Did I make a mistake or are we good? I think we're good. X plus 1. Can you pick your vertex out of there?
would you get the negative 2?
Because I said so that if we distribute it back in, it's really a 2, correct? But so we don't change the value of the problem, you're going to add the opposite of that so they would like cancel each other out, so be 0. So it's always the opposite. If this was a negative number, that would be plus. Good question. How about the vertex? Are we in agreement it's a negative 1, negative 3? All right, HK. Anybody know how to get the y-intercept from this guy? If I have a y-intercept, who is 0? X, right? So to do the y-intercept, you're going to take your original equation and plug in 0 for every x. And that's going to tell you your y-intercept is 0, negative 1. Now the x-intercepts, you're going to need to use the quadratic formula. We're doing this by hand. We're not doing it with the calculator. Hence the only reason you have 4, maybe 3.5 problems tonight. For time's sake, I'm going to just show you what the quadratic formula would give you. It's your negative b. We had this in this lesson, plus or minus b squared minus 4ac all over 2a. When you do that, you end up with a negative 2 plus or minus the root of 6 over 2. Those are your x-intercepts. If I don't ask you to graph, you can leave it like that. But if you have to graph it, you can do the decimals. Yes, Alyssa?
Why is the 4 not the first one?
Should be a plus. It's not going to matter when we solve it. Yes, I'll give you your point. Good job. If you, since it did say to graph, you could turn those into the decimals of negative 2.225 and 0, or the other one is 0.225 and 0. You do not have to graph tonight, so you can leave me those. Alrighty? And then if you did graph it would look something like this. This is just a rough sketch because I want to get to the homework one. But there you go. That's the directions tonight, only they say also do the domain and range. Use the key to help you tonight. So, after that, turn to number 17 in your homework. I want to go over, get that one completed, the square, so that we can make sure you understand where the values are coming from. All right. So, your directions tonight say analyze, but what that means is your x-intercept, your y-intercept, and the vertex, plus what they asked. To complete the square, this guy needs to be 1. So if I factor out that -2, can you tell me what I have? If I factor out that -2, can somebody tell me what I have left for the x squared? Anything or just x squared? Yes. That's going to be a -8x because I need a positive 16x. Remember, we've got to leave our space. We kick the constant out. So there's your spaces. Seriously, drawing the boxes helps me. All right, I want you guys to help me here. What do I do with that -8 in the middle to complete the square? Cohen.
So it's 1/2 squared.
Yes, so you take half of it, and then you square it. So do you all agree that we get 4, -4, squaring it, I get 16. Are you all in agreement? Okay. Really, it's a -32. So what am I going to put there to cancel it out so we don't change the value of the problem? Positive, yep. It's always the opposite. And then your vertex form, this guy factors x minus 4, quantity squared, plus 3. Did I add it right? Yeah. All right. And then you could do everything else. Yes, dear? Dang nabbit. No. It should. Absolutely.